Did you know the small block Chevy is 70 years old? That's right, the most influential engine in motorsports just turned 70, and we thought, what better way to celebrate that milestone than to build one? The first small block displaced only 265 cubic inches. It was designed by an engineer named Ed Cole, and he did it in 15 weeks, 70 years ago. And this engine was produced from 1955 to 2003. That's almost 50 years that this engine was installed in production vehicles, and you can still buy a new engine and a bunch of speed parts today. For our 70th anniversary small block build, we decided to go with a Summit Racing block. And the reason we did this is because it is just so much better than an original block. This is the 1969 block out of my Chevy wagon, and while it's crusty and greasy, it could absolutely be machined and restored and rebuilt, and I will do that at some point, but for this build, the Summit block is an excellent starting point. It's got priority main oiling, it's got Siamese cylinder bores, it's machined, with modern computer numerically controlled equipment, so it's really, really precise, and this block actually has a 4/165 bore compared to a 4-inch bore in a standard 350, and this block will take a 4-inch stroke crank. So where this is a 350 cubic inch engine, this is gonna be a 434 cubic inch engine, but it's gonna physically displace the same amount of area. It's gonna look like, your standard small block, but it's gonna be so much bigger and it's gonna make so much more horsepower because of that. So the premise for this build is it needs to look like a small block, but have a bunch more modern technology than an engineer like Ed Cole would have ever had access to back in the day. So we wanted to keep this period correct in appearance, but internally it's gonna be really cool. So this engine's gonna have a roller cam, it's gonna have fuel injection, it's gonna have a really long stroker crank, a very big bore, tons of displacement, some really trick cylinder heads. And we've only got a couple days to build this, so I invited my friend Mike over. He's gonna help me assemble this thing. Mike's built a bunch of small blocks. He's gone pretty fast with them. And we've gotta get this thing put together, and then we've gotta get it to West Tech by Friday for a dyno. So let's get some stuff done. All right, so the first step is gonna be to take the caps off the block. We're gonna mock up the crank. This is a 4-inch stroke crank, which is a lot for any small block. Most factory blocks won't take one. You actually hit the water jacket, so it's just not possible. The Summit block has a lot more stroker clearance, but we still need to put the crank in, put a piston and a rod in every cylinder, and verify that we're not gonna bump a rod bolt into the side of the oil pan rail. All right, our 4-inch forged stroker crank is in place. Mike is working on setting up a rod and piston. We're gonna put a rod and piston on each of the rod throws and run it through each cylinder and just make sure that if we're gonna have a clearance issue, we address it now before we get everything kind of assembled and just make sure that the whole rotating assembly has room to swing. All right, so we have our first rod and piston hung on the crank, and we're doing that to check for clearance. This is a really long stroke crank for a small block, so even though this block has a lot of extra clearance built in, for example, if we were building a 3.75 stroke 383, this would have cleared by a mile. Because it's a 4-inch stroke, there's a little bit of interference, so we're gonna grind on it, which is not hard, and it's the reason that we do these mock-ups and we check to make sure things fit before we start getting deep into assembly. All right, Mike and I just finished clearancing the entire block, which means we hung a rod and piston, put it on every journal and every cylinder, swung it around, made sure that the rod bolts had a lot of clearance. This thing's gonna turn a lot of RPM, and we wanted to make sure we had at least 30/10 of an inch in between the oil pan rail and then the rod and the rod bolt. That's done. Now it's time to take the crank back out, clean everything really good because we got this new SPC block very, very dirty, and we need to get rid of all that before we can start assembly. So out comes the crank and time to clean.
We've lightened it considerably.
Yeah, there's a little bit of iron on the floor. Mike's cleaning it out now. We got to get all the metal shavings out of it. So I am working on the piston rings right now, and I'm going to gap them. They're all file fit, so we're going to fit every single piston ring to the piston, to the bore that it's going to go into. And then these are really thin 1mm rings, so it's going to be a low tension ring pack, which is great for horsepower, great for resistance, frees up some horsepower. Let's get grinding. All right, I got one ring gapped. I'm gonna go ahead and install it in the bore. I like to take a second ring and then use my piston as a guide so that I can make sure that the ring is square. So when I measure it, my end gap is exactly what I want it to be. On this one, Mahler recommends 6 thou of ring gap per inch of cylinder bore. So this is a 4.165 bore times 6 thou is just a hair under 25 thousandths. So that's what we're gonna go. That gives us a little bit of sealing if we decide to make a bunch of horsepower later. We don't want these rings to get hot and butt. That lifts the top of the piston and it would be a big problem. This is a Scat H-beam rod and a Mala 4032 forged piston. This has a narrow metric ring pack, which is great for reducing friction. It is a forged piston, which means it's gonna take quite a bit of power. And now I'm gonna go ahead and hang the piston rings on it while Mike does bearings and the rest of the connecting rods. All right, we finished prepping the block. We've got clearance for the rotating assembly. That put a lot of metal everywhere, so we've gone through, cleaned the crank, cleaned the block, blew it all out, hit it with solvent. This is ready to go. Now Mike and I are just gonna work through putting all the pistons, the crank, the bearings, and get the bottom end completely buttoned up. Okay, so we installed our crankshaft and there was not enough thrust clearance. It made the crank a little bit hard to install. I've just done this a lot and I could feel that there was something binding, so we checked our end play. There was less than 1 thou, so I'm taking the rearmost main bearings and then putting these on a piece of marble with a piece of sandpaper and just opening them up a little bit to make sure our crankshaft has enough room to go forward and aft. If it's too tight, oil can't get in between the thrust bearing and the thrust surface of the crank, and it's gonna cause a problem and could cause something to seize or worse. So simple process of checking, putting a dial indicator on the front of the crank, and then massaging the bearings to give us the room that we need. We've reached the stage in the build where we need to tighten the connecting rod fasteners. Now, because this is a stroker, there's a lot of movement. That piston has to go really far up, really far down. There's a lot of load that these rods have to be able to take. Because of that, these are an ARP L19 alloy bolt, and we're gonna tighten them to 80 foot-pounds, which is a lot more than you would do on a conventional rod bolt, but this rod bolt is rated for that. So it's gonna get 80 foot-pounds, and then that will complete the bottom end.
We need to have some little explosions going on here, you know, like it's firing the cylinder.
So when we talk about this being a stroker engine and having a 4-inch stroke crankshaft, that is a pretty big deal for a small block. It never came from the factory with a stroke anywhere close to that 4-inch mark. So I thought it would be a great visual representation of what we're actually doing here to add displacement to this engine, to just use a tape measure and show you what, you know, the strokes on a small block would actually look like. So here's 4 inches. Now, if this was a 283, it would be about 3 inches of stroke. If it was a 327, it would be 3 1/4. If it was a 350, it would be about 3 1/2. We're all the way at 4 inches. So that is a tremendous amount of volume that we're adding to this engine, increasing the displacement and increasing the horsepower and the torque. All right, the short block on our Summit Racing 70th anniversary small block sleeper is done. The next steps are gonna be to put the top end on, turn this thing orange, and start hiding some horsepower parts, so make sure to check back next time as we do the top end.
Yeah, I'm gonna just back up a tad there.
That's the beauty of the keyway socket, is that you don't have to do a full revolution.
I could have, though. I could use the exercise, you know. I haven't been to the gym since May.
This is my gym.
Uh-huh.